Alright, so let's, I think I'm recording here. Let's take a look at this application problem. We have a Ferris wheel, and we've seen one of the Ferris wheel problems in a previous homework. We have a maximum height of a Ferris wheel of 64 feet. The wheel takes 72 seconds to make one revolution. Passengers board the Ferris wheel 6 feet above the ground at the bottom of its rotation. Um, Answer the following questions. Write an equation to represent the position of a passenger at any time t in seconds. So let's y equals 64 is our max. Y equals 6 is our min. If we add these together, that's 70, and half of 70 is 35. So y equals 35 is our center line. Um, 20, 29 is the amplitude, because if we take 64 minus 35, isn't that 29? Yeah, it should be. And it's 29 feet, right? It tells us that 72 seconds is the length of time that it takes to make one revolution. So there's our period. And it says assume that the clock starts at 0. So at time t equals 0, when you're at the bottom of the Ferris wheel. So then the next time that you're at the bottom, that is 72. Um, half of 72 is 36. Half of 36 is 18. So if we add 18 to that, is that 54? I should check this because I'm not that great at mental arithmetic. If we take 72 and divide it into 4 equal pieces, we have 18. If we add 18, 36, add another 18, and should get 54. Yeah. Okay, so we're all set. Now, let's, how long until the passenger is at the center line for the first time? So it's kind of giving us a clue as to what to pick as a starting point if we want to write a sine curve. So let's have our starting point here at 18. So how long until the passenger's at the center line for the first time? Well, in 18 seconds, after boarding, because it told us to start the clock when they boarded at the bottom. Um, oh, here. And now let's see if we can write the equation. We've got this function of time. We have an amplitude of 29. We have 2 pi divided by the period of 72. We have a shift to the right, 18 units. So actually to the right is subtraction. And we had a vertical shift to get to the center line of up 35. So the only thing that we can do, I suppose, here is reduce this fraction to pi over 36. So let's do that. Alright, so there is my equation for this problem. Hope that helps. Let's take a look at the next one here. We've got a tide problem. There's a high tide and a low tide in these tide problems. And we've seen one of those in the homework assignments previously as well. The water in Hideaway Bay reaches a minimum depth of 18 feet at 12:30 a.m. and at 6 a.m. the water has a maximum depth of 30 feet. Answer the following questions. Write an equation that represents the depth of the water at any time t in hours after midnight. So we have a minimum depth of 18, a maximum of, where'd it go, 30. So if we add these together, we get 48, and half of 48 is 24. So my center line is y equals 24 feet. Alright, so let's see. We want to work in hours, and we want to start at midnight at 12 a.m. So at 12:30, that's t equals 0.5, that's half an hour later, we're at a minimum depth. So here I'm at a minimum depth, and I can call this t equals 0.5. Alright, and then at 6 a.m., that's 6 hours after midnight, we're at a maximum depth. So 6 hours after midnight. Alright, now the distance between a max and a min is half of the period, because here's the full length of the period. 6 minus 0.5 is 5.5. So this is 11.5, and the period then is 11 hours. Right? Now let's look at a fourth of the period, because this is our equal spacing, 2.75. So if we take 0.5 and we add 2.75, then we'll be up at that center line. That's 3.25. If we add another 2.75, we should get 6, because we'll be up at the max, and we do. If we add another 2.75, we're back at the center line. 8.75. And then just to check, 2.75 should be at 11.5. Yeah, okay. So our spacing looks good. The amplitude, 6 units above 24 or 6 units below 24 is our max and min. So our amplitude is 6 feet. How long in hours after midnight until the water's at the center line for the first time? So 2.75, if you back up it wasn't, somewhere in here is where t equals 0 is. So for the first time, it's right here, 3.25 hours. 3.25 hours after midnight, then the water will be at the center line for the first time since we started at t equals 0. Alright, so let's use that as a starting point and pick this as our basic cycle here for the sine curve. So we've got y is equal to the amplitude of 6 times the sine of 2 pi divided by the period, which is 11, and you can use x if you want. I use time a lot of times because, well, it tells us to. It says t in hours. I'm not going to be upset if you use x, however. We have a shift to the right, but that's bizarre in its behavior when it affects the domain, so it's t minus 3.25. And then we have a vertical shift. We're taking the sine of this product, and we have a vertical shift of 24 feet. Alright, so there's our equation for this. Hey, I hope that helps. Let's look and see what else we've got. Alright, so I'll do this on another video.